In this video, we will learn the reactions that are ran by forming benzene intermediate. In this reaction, we need aryl halide as an initial compound, and aryl halide is a type of aromatic halogen compound. So aryl halide, when treated with strong base, undergo elimination addition reaction. So guys, first of all, don't watch the remaining parts, just focus on the part which I am pointing out first. So aryl halide, when treated with strong base, undergo elimination addition reaction. Elimination addition because in the first step of this reaction it occurs an elimination of halogen atom, and the next step is the addition of nucleophilic group. So it is one type of aromatic nucleophilic substitution reaction, and the reaction proceeds via an intermediate called benzyne. In these elimination reactions, the entering group may or not always occupy the position vacated by the expelled group. Expelled group means that the group that is getting evicted. So initially I have said you that in this reaction the first substrate is aryl halide. So aryl halide makes a product by forming benzene intermediate. So in this type of reaction there are required two type of conditions. So the first condition is aromatic ring must have a hydrogen atom adjacent to the carbon atom with which the halogen atom is attached. Very strong bases like NaNH2 in liquid NH3 or organolithium compound etc. has to be employed to perform the reaction, because as first step of the reaction needs an elimination, so definitely only very strong base can initiate the reaction. So let's see the first step of the reaction. Here you can see aryl halide compound. Here X is halogen compound, fluorine, chlorine, bromine, iodine, and R is substituent. So when we put aromatic halogen compound or aryl halide in NaNH2 liquid NH3 medium, we already know that in this medium they are present Na plus cation and NH2 minus anion. So these NH2 minus anion first abstract the alpha hydrogen adjacent to the carbon atoms to which halogen atom is attached, and they form a negative charge on this carbon atom on which hydrogen atom was attached. This negative charge is then delocalizes to the aromatic ring, eliminating the halogen compound, and this intermediate is called benzene intermediate, in which there is an extra pi bond outside the benzene ring. It seems benzene contains a triple bond, but remember this triple bond in benzene intermediate is not like the triple bond in acetylene. A linear acetylenic linkages in which bond angle is 180 degree cannot be formed in benzene due to the hexagonal geometry associated with this benzene ring. This was your orthohalide, but on the next we will move on to the parahalide, and here the benzene intermediate is to formed, and the same process which I have described you just now. So what happen if halogen atom is present at meta position? Then the same reaction will happen, but this time there are two halogen atoms, two alpha hydrogen atoms are present in this aryl halide. So in this process, if you observe carefully, you will find that the two benzene intermediate forms from this metahalide is the same that form from parahalide and orthohalide respectively. Now the stability of the carbon ion and the stability of the benzene intermediate is depend on the nature of R group or the substituent. So if the substituent is electron donating or it donated electron by plus I effect, then the respective carbon ion will be stable only if the negative charge on the carbon ion is present at C4 carbon atom of the benzene ring. This is because in plus I effect of the substituent, that is R group, localization of negative charges occur most for carbon ion at C2 as it is closest to the R group, and least for carbon ion at C4 as it is farthest to R group. Therefore, electronic repulsion is most at C2 compared to C4. That is why C4 carbon ion get its most stability, and the benzene intermediate formed from this carbon ion will be the major product. and the another benzene intermediate that is formed by this carbon ion will be minor in production. Similarly, if the substituent shows minus I effect, that is withdrawing electron from the benzene ring, delocalization of negative charges occur most for carbon ion at C2 compared to C4 carbon ion, as C2 is closer than C4 to R. Hence, electronic repulsion is maximum at C4 compared to C2. Hence, C2 carbon ion is stabler. That is why benzyne intermediate formed from C2 carbon ion will be major in production, while benzyne intermediate from C4 carbon ion will be minor in production. Now, the second step of the reaction is when a nucleophilic substituent like NH2- attack the benzyne intermediate and form nucleophile substituted product. Remember, here it is called nucleophilic. Nucleophilic means nucleus loving. That means it is attracted by the positive charge, and definitely it must have unshared electron pair or negative charge with it. So, in the second step, NH2- can attack the benzene intermediate from two sides. So, when NH2- attack from this side, this carbon ion is formed, and again the negative charge in this carbon atom gets a proton from NH2 molecule present in this medium and thus become uncharged product. Again, when NH2- attack from this side, we get this product with no charge. Again, in the same case, when the first product will be the major if R is electron donating or donating its electron through plus I effect. Again, due to the plus I effect of R group, the localization of negative charges occur most for C2 carbon atom than for C3 carbon atom, as C2 carbon atom is closest to the R group and C3 carbon atom is farthest to R group. That is why C3 carbon atom will face relatively less electronic repulsion compared to C2 carbon atom. That is why the product formed from this carbon ion will be major when R group is electron donating. On the other hand, the second product will be the major when R is electron withdrawing. When R group show minus I effect, delocalization of negative charges occur most for carbon atom at C2. That is why carbon ion having negative charge at C2 position will face less electron repulsion, and that is why it becomes stable, and the product formed from this carbon ion will be the major in this reaction. Remember, this benzyne is called 2,3-arine because it involves C2 and C3 carbon atom of the benzene ring, and this benzyne intermediate is called 3,4-arine because it involves C3 and C4 carbon atom of benzene ring. In this case, if the R group in the carbon ion shows plus I effect, it becomes unstable because localization of electron occurs in C3 carbon atom, that is compared to C4 carbon atom at the second product. That is why C3 carbon atom will face more electronic repulsion than the C4 carbon atom of the second carbon ion. So, the first product will be major. That is how the second carbon ion will get more stability than the first carbon ion, and the product from the second carbon ion will be the major when R group will have plus I effect. But if R group have minus I effect, first carbon ion will be more stable because the delocalization of negative charge occur most for carbon ion at C3 carbon atom while carbon ion at C4 carbon atom. That is why product formed from first carbon ion will be the major product. So now solve some question relating to it to get more clearer concept regarding it. The question is, what happens when metachlorotoluene is treated with NaNH2 in liquid ammonia? As for metachlorotoluene, there is two alpha hydrogen atom. So when NH2 abstract this hydrogen atom, the two product will be this. And earlier I have told you, when R group, that is a substituent, will have plus I effect, then the carbon ion formed from benzyne intermediate having negative charge in C3 carbon atom will be stable than the carbon ion having negative charge at C2 carbon atom. So the major product formed from this reaction is orthotoluidine. Again, when NH2 group will attack benzene ring from or alpha hydrogen atom from this side, they form these two type of carbon ion from benzyne intermediate. Now, as the CH3 group that has plus I effect donate its most of its electron density to the C3 carbon atom compared to C4 carbon atom. That is why C4 carbon atom will face less electronic repulsion than C3 carbon atom, and hence C4 carbon atom will be more stable than C3 carbon ion. Is why in this case metatoluidine will be the major product. Now the next question is, what happens when ortho-trifluoromethylchlorobenzene is treated with sodamide in liquid ammonia? In this case, there is only one hydrogen atom is available, and the reaction occur in the same way that I have discussed earlier. Here, the R group, that is the substituent group, is trifluoromethyl group that shows minus I effect or withdraw electron from the aromatic ring, and thus delocalization of negative charges occur most for carbon ion having negative charge in C2 carbon atom than carbon ion having negative charge at C3 carbon atom. That is why carbon ion having negative charge at C2 carbon atom will be the stablest one. That is why product we get from this carbon ion will be the major product in this reaction. So I hope guys I am able to teach you the fact of benzyne intermediate. So in the next video we will solve some different type of question or some harder question from this topic to get more clear overview of this topic, and also I will discuss how questions asked from this topic in various examination. Stay tuned and don't forget to like, share and comment. If you have liked this video, don't forget to subscribe. Thank you for watching.